තීක්ෂණ තීක්ෂණ கேமரா வந்து கிளியர் இல்லையா அப்படின்னா அந்த டார்க்கா இருக்குதா அதை தீக்ஷணை சொல்லுங்க செட்டிங்ஸை கொஞ்சம் செஞ்சு பிரைட்னஸ் இன்க்ரீஸ் பண்ண சொல்லு. How about now, online students? All good now? Okay. If there is any issue, quickly drop a message, okay, in the online class because I can't check. Okay, if there is any issue, yeah, we'll see. Alright, okay, okay, okay. So I'll make up with the physical students and I will be starting. Okay. Okay. Shh, 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 shh. Uh, Good morning. Good morning. Morning. Is it good? Okay. So, few people are missing. Still, they have to come. Okay, let's start. It's already 9 o'clock. You all can hear properly, right? Is the audio enough? Is it enough? Can hear back? Can't hear. How about now? Can hear now? Now okay. Is it enough? Okay, take the tutes. Okay, so you all know what is the topic today. This is a part of your unit number. From which unit this part is tested? Unit number 6. Okay, the networking, data communication and computer network lesson. A small part which is known as IP address and subnetting. But even though it is small, okay, it is tested every time in the exams. In question number, what question it is tested? In your final paper, question number 6, the unit 6, question number 6, it is tested. Okay, so this IP address and subnetting part, logically, if you are trying to understand and do, it will be little difficult. Okay, but there are shortcuts. Okay, how to identify them and how to do them properly. It's very easy. Okay, so all the steps related to IP address subnetting and all the details which you should know is included in the relevant tute. Okay, Hari. So starting with the first topic, which is IP address. Okay, so if you take a computer or if you take a mobile phone or any electronic device, okay, it will mainly have electronic communication device. It will mainly have two types of addresses. You might already know. What are the two types of addresses? Huh? IP address and the MAC address. IP address stands for Internet Protocol Address. MAC address stands for Media Access Control Address. What are these two addresses? In your computer, in your mobile phones or whatever the device, if that device can connect to the internet, okay, ability to connect to internet. If a device has the ability to connect the internet, there should be a relevant device inside your device, which means inside the computer, there should be a small chip. That chip is the device which will provide the ability to connect to the internet for the device which you are using. In your mobile phone also, you will have it. In your computers also, you will have it. If there is a smartwatch, if the smartwatch can be connected to the internet, then also you should have this particular device which provides the ability to connect to the internet. What is that device? What is that device? Huh? What is the device? NIC. That device is known as NIC, which is known as the network interface card. So in all the computers, if you can connect to the internet, okay, not you are connected to the internet, if you can connect to the internet, if you have the ability to connect to the internet, that particular device should have what? Have an NIC, network interface card. If your computer, mobile phone, or any device has an NIC inside that, that particular device will be provided with a MAC address. So what is MAC address? That is an address which is provided to the NIC of a device which will provide the ability to connect to the internet. Okay, from your mobile phone, can you connect to the internet? Yes. So will it have an NIC? Yes. From a smartwatch, can you connect to the internet? In some watch you can. So that will have an NIC. If not, if you can't connect, then that won't have an NIC. If you have an NIC, definitely that will have a MAC address. That will have a MAC address. Okay. So in your computer, you have a NIC, you have a MAC address. Now what you do? Now you connect to the internet. When you are connected to the internet is a global village, which means wherever you are, if you are connected to a particular device through the internet, okay, you should be identified uniquely in the internet. Okay, so once you are connected to the internet, a unique address called IP address will be provided to you. Okay, so will all the computers have an MAC address most of the time? No, you can't say like that. You have to say all the NICs will have a MAC address. Okay, all the network interface will have a MAC address, not all the computers. If you have a MAC address, definitely will you have an IP address? No. MAC address will provide the ability to connect to the internet. Okay. NIC, the IP address will be given if you are connected to the internet. If your device is offline, will it need an IP address? No. If your device is online, which means on the internet only, you will be given an IP address. Okay, Hari. So now, what is IP address? Unique address which is provided to any device which is connected to the internet. Now understand this concept also. Any IP address which is detected publicly on the internet, we call it as what? Public IP address. We call it as public IP address. So what is a public IP address? If your IP address is visible on the internet, okay? If they want to send you a message, your IP address should be visible in the internet, okay? Those IP addresses, we call it as what? Public IP addresses. Okay. And now, if you take a network, you all know what is network. What is a network? A main device will be there, which could be a router or a switch or whatever, and all the other devices will be connected to this router. This is a switch, there will be several computers. This is a switch, there will be several computers. All of them will be connected to a router. Now, if you want to access the internet with the help of a network, which means your phone, okay, your phone which is in your hand is just a phone, okay, it's not inside a network. But if you take an office, if you take a school, all the computers inside those school will be connected to a network, which means if you want to access the internet, you have to access through one router, which means in your home, if 5 devices are connected to the Wi-Fi, Wi-Fi is the one who is going to have the public IP address, not the devices which are connected. The devices which is connected to the network will have a private IP address. For example, this computer will be given with a private IP address. Okay, this computer will be given with a private IP address. If this computer needs to access the internet, that will go to this switch, come to this router. Through the router only it will access the internet. The router will have a public IP address. Okay, router will have a public IP address. So whatever the networks or whatever the devices which is active in the internet will have an IP address, that is the public IP address. The networks, inside the networks you have some computers, those devices will have a private IP address. Okay, and why did I explain this? Remember, there is a concept called subnetting. Okay, there is a concept called subnetting. I will explain what is subnetting. But remember, subnetting can be done only for the private IP addresses. You can't do subnetting for the public IP addresses. Public IP address is one address which is solely represented in the internet. Private IP addresses, you will buy an IP address, you will divide it across your computers and allocate it. I'll explain the process. You have to remember one thing, whatever we are going to apply in this session afterwards, which is called as subnetting, will be applied only for the private IP addresses, not for the public IP address. Public IP address uses only one. What is that? Like uniquely representing your computer or the device in the internet. Private IP addresses have several purposes. Okay. So now let's move on to the format of an IP address. How an IP address will look like. IP address are consisting of two types, which is IP version 6, version 4 and the IP version 6. There are two types of IP addresses. Okay. So recently, nowadays, we are now changing into the IPv6 address, which is IP version 6. But when this syllabus of yours was made, the popular type of IP addresses which we will be using, which we were using was what? The IPv4 addresses. So what is this IPv4 addresses? It have 32 bits in its address. It have 32 bits in its address. I'll explain how this works. Okay. But once you made this IP address, when you are allocating this IP address for devices and devices, over the time, the number of devices will be increasing. So the IP version 4 addresses are finished. Okay, we still have it, but it's now going to reach the end. So what we are doing, we are moving into the IP version 6, which is the present context. But according to the syllabus, we just have introduced IP version 6 Currently, we are using IP version 4 according to the syllabus. Okay. So now IP version 4 consists of 32 bits. IP version 4 consists of how many bits? 32 bits. But IP version 6 consists of 128 bits. Okay. So now listen carefully. If you are using an IP version 4 address, it will be represented in 32 bits, mean 32 binary numbers like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Like this, 32 bits will be there. These bits will be divided into 4. These bits will be divided. 32 bits will be divided into 4, which means 8 bits. මෙන්න මේ විදිහට 8 bits වලට this will be divided. Okay. This each 8-bit set, we call it as an octet. Okay, that is the name. 8 bits is a octet. Okay. So this is octet 1. Like that, how many octet we will be having? We will be having 4 octets. This is the first octet, second octet, third octet, and the fourth octet. So 32-bit binaries are there. It will be divided into 8. So divided into 4, each consisting 8 bits. So one set of 8 bits, we call it as an octet. So how many octets are there in an IP version 4 address? There are 4 octets, which consist 8 bits each. Okay. And remember, both the IP version 4 and IP version 6 will be represented in what? Will be represented. The original version of the IP addresses are in binary format. All the IP addresses, IP version 4 or IP version 6, both of them are represented in binary. Both of them are actually in the context of binary numbers. But for the humans, it will be little hard to communicate with the others if the IP addresses are this much long. Okay, which mean in binary bits. So what we are doing is we are converting it into a format which is suitable for the human to understand, which mean IP version 4, we represent it in decimal. IP version 4, we represent it in decimal. And IP version 6, in what format do we represent? Is it decimal? Then hexadecimal. Same like the MAC address, this will be represented in hexadecimal. Okay, so about the IPv6 address, you just have to know, according to our syllabus, you just have to know how many bits are there. 128 bits, and it is represented in what? Hexadecimal. But about the IPv4 address, you have to know certain lot of information, which means how many bits are there? 32 bits, okay, represented in decimal. The binary bits, it will be divided into 4, each consisting 8 bits. One 8-bit set, we call it as octet. There are 4 octet. Original format is in binary, represented in the decimal format. Okay, keep those things in mind. Hurry. So now the format of an IP address is like this. No, මෙන්න මේ විදිහට තියෙනවා. Okay, so if you take this IP address, okay, listen carefully. If you take this IP address in one particular octet, you have how many bits? 8 bits are there. What is the maximum value you can put here? In binary, 8 ones. That is the maximum value you can put. Okay. What is the minimum value you can put here? 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. If you put all ones, what is the value? 255. Binary to decimal conversion. If you put all zeros, what is the value? 0. So see the range of an IP address. When you are representing it in the decimal format, it could differ from 0.0.0.0 to what is the maximum you can go? 255. So which is 255.255.255.255. Because in each bit you have 8 bits, right? In each octet. So 8 bits, if you put all ones, that is 255. Can you go beyond that? No. If you put all zeros, that is going to be 0. Can you go below that? No. So the minimum IP address is this, maximum IP address is this. So if they ask you what is the first IP, okay, most of the time it's not first IP, we call it as minimum IP. What is the minimum possible IP? That is 0.0.0.0. What is the maximum possible IP? That is 255.255.255. So this is the maximum and minimum IP addresses. Okay, so you should keep those things in mind. Okay, and if I give you an IP address like this, okay, now tell me, is this a valid IP address? Is this a valid IP address? First octet, is it within 0 to 255? Second one, third, fourth, yes. So is it a valid IP address? Yes, it is a valid IP address. If you take this, is it a valid IP address? Yes. This, no. Why 256 is not a valid IP address? Okay, so like that only you have to identify the validity and the invalidity of an IP address. Okay, so these are the contexts you will have to know about the IP address. Once again, okay, in your particular, okay, in your particular computer, if you want to connect to the internet, you should have a device. What is that device called? NIC. If you have an NIC, you will be provided with a MAC address. Okay, you will be provided with a MAC address. Okay, and if you have the MAC address, can you connect to the internet? Yes. While you are connected to the internet, you will receive an IP address. Represented in the internet mean that is the public or private IP? Public IP address. If you are inside a network, your device will be provided with a private IP address. The Wi-Fi or the router will be provided with a public IP address. Okay. IP addresses are of two versions. What are them? IP version 4 and IP version 6. IP version 4 has how many bits? IP version 6, both of them are originally represented in binary, but IP version 4 in human easy format, decimal. IP version 6, hexadecimal. IP version 4 totally has 32 bit, which will be divided into 4. Each 4 bit, sorry, each particular of this will be called as what? One part will be called as octet. That will consist of how many bit? 8 bits. So there will be totally 4 octets. So if you put all zeros, the value will be 0. If you put all ones, the value will be 255. So the minimum IP address you can have is 0000. Maximum IP you can go is 255. Was it clear? Okay. So quickly take a note of this. Okay, shh. Listen. So now you all know what is the range of IP address from 0.0.0.0 to the maximum IP address, which is 255.255.255.255. So now you are going to divide those IP addresses into classes. Okay, I'll explain what is the reason. The first thing you have to know here is, okay, when it is divided into classes, you will be dividing it by particular slots. Okay, from 0 to this much class A, from 0 to this much class B, like that you will be divided. So in that case, okay, so in that instance you can see if your IP address is from 0.0.0.0 to 126.255.255.255.255. Okay, so if it is within this range, your IP address, if it is within this range, it will be considered as a class A IP address. Okay, this will be considered as a class A IP address. Why class A? I'll explain the reason. So now, if your IP address is 128.0.0.0 to 191.255.255.255. This will fall into a class B IP address. And if your IP address range is from 192 to 192.0.0.0 to 223.255.255.255, that will fall into class C IP address. Okay, so now listen carefully. Class D and E, we use it for separate context. You will understand. Okay, so now what is these IP address slots? If you are a company, okay, if you are a company, imagine you have 5 computers, okay, no, 50 computers in your company. Okay, you will have 50 computers in your company. Okay, so I have taken a sample of 3 computers. Now, if my IP address is like this, see, listen carefully. This is one company and the IP addresses looks like this. Okay, I'll get another company. In that, the IP address is going to look like this. Okay. Now tell me, the first diagram, I have allocated some IP address, and in the second diagram, I have allocated some IP address. Which would be more suitable to be allocated for a company devices? Now see this IP address, 192.168.0, this is computer 1. 192.168.0, this is computer 2. 192.168.0, this is computer 3. But here if you come, it's not a fixed IP address. You can see it's blabbered here and there. You won't be able to identify what is the IP address which is for allocated for your company properly. Which method is more suitable? Is it going with this or that? This is okay. Okay, this is okay. So if you want a fixed set of IP address for your company and the last octet you can change and allocate for the devices. Okay. So formatting එක 192.168 whole company එකටම whatever the devices you have, format is going to be 192.168. According to the computer, the last or last before octet could change. If you need something like that, you will have to buy an IP address set from whom? From an internet service provider. From an internet service provider, you have to buy an IP set. If you go and buy a SIM card, your SIM card will be given an IP address and a MAC address by Dialog, Airtel, whatever the IP address, whatever the SIM you are buying, IP address will be provided. At the same time, if you are a large company, in your company there are around 50-60 computers or 500,000 computers, you have to go for an internet service provider, ISP, and you have to say that we have a set of this much of computers, we have to connect them to the internet, provide us with a suitable IP address. So they will provide you with an IP address. You have to purchase that IP address. Once you purchase that IP address by giving it to your relevant person like that network administrator or someone, you can allocate it for your computers. Then the IP address will look like this. But if you just go buy a SIM, put it to one device, buy a dongle, put it to another device, use a Wi-Fi, connect some other devices. If you do it that way, your network won't be aligned properly. It will be looking like this. So it will be hard for your computers internally to communicate as well. But if you have a set of IP address like this, internal communication between these devices also will be very easy considerably. Okay, so that is the concept. So if you want to go and get this kind of an IP address, you have to go to an internet service provider, buy a slot of IP address for yourself. Okay, so at that time, they will decide whether you are going to get class A IP address, class B, or class C IP address. Okay, so if they give you an IP address which is in the range of 0.0.0.0 to 126.255.255.255, if they give you one IP address within this range, you can allocate that IP address for 16 million devices. How many devices? 16 million devices. If they give you an IP address within this 128.0.0.0 to 191.255.255.255 range, if you buy one IP address from this range, you can allocate it for 65,536 computers. Okay. If you buy an IP address within this range, you will be able to allocate it for 256 devices. Okay, so keep this context in mind. Now, I got an IP address. That IP address is this. මෙන්න මේ IP address එක I got. Hari, this particular IP address I brought. Now, what is the class of my IP address? Class A. How many computers I can allocate using this? 16 million computers, which means they will give you the ownership of 10.0.0.0 to 10.255.255.255. This whole range I will be given control. Okay, so you can see this particular part will be fixed. This particular part will be changing. Okay, that is the format of a class A IP address. Okay, this is a class A. Okay, this is a sample. If you buy 11 also, 11.0.0.0 to 11.255.255.255. If you buy, you can take like 125, then you will get the control of 125.0.0.0 to 125.255.255.255. So simply remember, if you buy a class A address, you will get control of how many octet? The last 3 octet you will get the control of. Okay, not much complex. In class A, you will get the control of 3 octet. First octet will be provided by the internet service provider. If you buy one, how many devices you can allocate it? 16 million devices. Usually, a company won't buy this type of IP address. Usually, who buy this type of IP address is the telecommunication service companies. For example, Dialog will have a class A IP address. Reason is when they sell a SIM card, they have to allocate a particular IP address for the SIM card. No? Okay, like that, they will sell it for a large amount of people. So they will need a large amount of what? Large amount of IP addresses. So companies like Google, Facebook, okay, if you take the telecommunication service providers like Dialog, Airtel, they will be using this class A IP address, not the normal ordinary companies. Okay, then when you come to class B, now I'll say a range that is going to be like 185. I bought this IP address. What is the class which is belong to? What is the class it will belong to? Class B, which means how many IP addresses you will be getting? 65,536. So remember, if you buy a class B IP address, you will get the control of the last 2 octet. Okay, මම මෙතන change කියලා mark කරන්නේ how much octet you will get control of. Just keep that in mind. In class A, how many octet you got control? 3. In class 2, sorry, class B, 2. In class C, it would be 1. Okay, so now see, this is a sample of class B IP address. Okay. So now if you go and buy a class C IP address, this IP address, to what class does it belong to? C class. So how many IP addresses you will get? You will get only one IP address, and you will get the control of what? You will get the control of the last octet, which means this octet only you can change. So this is a sample of class C. Okay, you will get it more, Hari, but for now just remember class A IP address 16 million addresses, class B means that is going to be 65,536, class C means that is going to be 256 address. In this order you can see 0 to 126, 128 to 191, 192 to 223. Something is missing. In this flow, something is missing. What is that? 127 is missing. So remember, 127.0.0.0 to 127.255.255.255. This particular range is missing from this class. Can you see that? This particular range is missing. So why is it missing? Because we don't use it for devices. We use it for a purpose called loopback testing. Okay, if you have a newly launched website, before putting it to the internet, you will have to put it to a particular server and test them, whether it's working properly. Okay, if you launch a new mobile phone, that mobile phone, before it is available in the internet, you should put it into a sample server and test whether that mobile phone is working. If you have a like created a new device like a smartwatch or something which is connected to the internet, you have to connect it to the internet and test it. But at that time, when you are putting it to the internet to testing purposes, you don't put it to a network where it is publicly open for everyone. You should be in a hidden server. That hidden server which is used for the testing purpose is what server? This 127 to 0.0.0.0 to 127.255.255.255. So this range is falling under loopback testing. Does it fall under any classes? No, it doesn't fall under any classes. Okay, so A class means 16 million address, B class means 65,536, C class means 256 address. What about D and E? Remember, D and E we won't be, you can see the range in the tune, but we won't be using it for the devices. If there is any government authorities, okay, the research purposes, special organizations like this NASA and all, so all of them will be provided with some special set of IP address which will belong from class D and E. So you can mark down for class D and E, you can mark down it is used for special purposes, special and research purposes. Special and research purposes. Okay, so now see, so what are the classful IP addresses which can be allocated for devices? That is going to be class A, B, and C. And in that also 127 range, will it fall under any class? No. Why we use it for loopback testing? Okay, so now listen carefully. There is a problem with these classful IP addresses. There is a problem with these classful IP addresses. You can see if you buy a class A IP address, you will receive 16 million addresses, right? You will receive 16 million addresses. If you buy a class B, total of 65,536. And if you buy a class C, you will get only 256 addresses. Okay. So now only the calculation parts and everything will be starting. Listen carefully. So in your company, imagine there is a company. In your company, there are 500 devices. How many devices are there? 500 devices. And you need to connect all of these devices to the internet in the same format, which means you have to buy a set of IP address from whom? From the internet service provider. Are you going to buy a class B, A, or C address for allocate for these 500 computers? Class C, if you buy them, you will be given how many addresses? 256. Is it enough to allocate 500 devices? No. So some might say we can buy two class C IP addresses, but the formatting will be changed. You will get 192.168.0.0 and 200.0.0 also you might get. So that's not suitable. You have to go with one set of IP address. So if class class C is not enough, then you have to go for class B. Okay, so for this, what you are going to buy? You are going to buy a class B IP address. Class B IP address. If you buy a class B IP address, totally how many addresses will you get? 65,536. But how much will you use out of them? 500 will be used. So if you use only 500 out of them, remaining will be how much? 65,036. Can you allocate it for any other devices? If you have the devices, you can allocate. But for other people, can you give this? You can't give them. Only you will be owning this. So if you have 65,036 addresses remaining, and if you can't use it, and if others also can't use this will be a wastage. This will be what? This will be a wastage. Okay. So class full IP addresses, fella, there is a issue. What is the issue? If your number of devices does not suit the class properly, you will have to waste a lot of IP. For example, if you have 60,000 computers, buying a class B is okay. If you have 65,000 addresses, computers also, it is okay. But having 500, and if you have to go for 65,000, isn't it a wastage? It is a wastage. So you have to avoid it. So in order to avoid this only, okay, to avoid the wastage, to avoid it, we will be avoiding the class full IP address and we'll be moving into something called classless IP address. Okay, we will be moving into something called classless IP address. So all your subnetting and all the stuff will be based on classless IP address most of the time. In class full, they won't give. Okay, so if you take a classless IP address, what is the thing that is going to happen is they will allocate you the required number of addresses. Okay, allocation of required number of devices, allocation of required number of IP address as a power of 2. As a power of 2. Okay, what does this mean? Listen carefully. They will allocate you IP addresses based on your requirement, but they will allocate it as a power of 2. For example, if you need 500 devices, if you have 500 devices, okay, 65,000 is a wastage, right? So you have to go for a classless IP address. What is this classless IP address? They will allocate you the number of addresses based on the 2 to the power. Now tell me, if you want to cover 500, what is the nearest 2 to the power you are having? 2 to the power 1 is 2. Then 4, 8, 16, 32, 64, 128, 256, 512. So is 512 addresses enough to cover 500 devices? Yes. So they will allocate you, in order to cover this in classless, they will allocate you how many address? 512 addresses. Okay, in 2 to the power, they will allocate you. Okay, so how do we identify whether a IP address is a classful or classless IP address? Now I'll give a sample IP address that is going to be 192, sorry, we'll take a classless, make class B1, 172.0.0.0. This IP address you have. Tell me, what does this IP address, to which class does it belong to? What class does it belong to? Class B. How many addresses you will get? 65,536. So if it is a classless IP address, remember, you will be given an IP address like this. Like this, they will give you the IP address. Okay, IP address this is known as a class B IP address. this will be considered as a classless IP address. Why do we consider this as a classless IP address? This particular part is what we call it as a CIDR notation. We call this as what? CIDR notation. CIDR stands for classless interdomain routing. Classless interdomain routing. Hare. So that is the standard form of CIDR, classless interdomain routing. At any instances in your IP address, if you have a CIDR notation, definitely that will belong to a classless set of IP address. Okay. Now what is the class of this IP address? What is the class of this IP address? Class. Now classless. At any instances, remember, if you have the CIDR, that will be a classless IP address. CIDR mean that stands for classless interdomain routing. Okay, we'll do one more recap. There are classes of IP address. Okay, from 0 to 255 is the total range. We divide it into how many classes? 5 classes. Out of that, 3 classes can be used for allocating to the devices. Those are class A, B, and C. Class A is 0.0.0.0 to 126.255.255.255. Do we have to memorize the ranges? No. Yes, you have to memorize the ranges. So if you have class A IP address, to how many devices you can allocate it? Do you have to remember that? Yes. Okay. Then 127.0.0.0 to 127.255.255.255 belongs to what? Loop back testing, which means whenever you are launching a new device or a website or whatever the server, you can test it on that particular IP address range. Okay. Then class B starts from 128.0.0.0 to 191.255.255.255. Memorize the ranges, huh? And that will have how many IP address? 65,536. And class C, 192 to 223. Class D and E can be allocated for the computers? No. So it is for the research and the special purposes. And then if you take a classful IP address, what is the problem in classful IP address? The wastage will be high. In order to reduce the wastage, you can shift to a classless IP address. How do we identify a classless IP address using the IP? Using the CIDR. CIDR is represented in slash and the relevant number. After that, how to find the address using that we will tell. So CIDR stands for classless interdomain routing. And the number of addresses will be allocated in power of 2. If you need 1000, if you have 1000 devices, how many addresses will be provided? 1000 devices you have. To the power link to cover 1000? How much? 1024. If you want to have 100, if you have 120 devices, they will allocate you 128. If you have 12 devices, you can get a 16 address set. Okay, if you have 2000 devices, 2048. If you have 8000 devices, 8192 devices, addresses. Like that, you will get in powers of 2. Okay, to the power 1, 2, 3 until 13, 14, or a particular very big range also it can go. First, did you understand the purpose of classful? Why classful is not efficient? Use of classless? Yes, classless. Use of classless. What is the use of classless? Use of classless, you can allocate it to reduce the wastages. In classless, IP addresses will be allocated as a power of 2. Keep that in mind. And also, you have to remember the extended form of the CIDR, and CIDR will be represented in slash number. Slash and a number, it will be represented. Okay. So how to identify the number of addresses using CIDR and the other relevant parts now will be starting. So make sure this you have in the book. Make sure to write this down quickly. Okay. Listen. So now, Aganda. So now you have to know if they give you a certain CIDR, how you are going to find the number of addresses using the CIDR. Okay. For example, you are going for a relevant internet service provider. You say all your requirements. They give you an IP address. What is that IP address? For example, they give you an IP address 192.168.0.0/23. Like this, they give you an IP address. Does it belong to a class? Does it belong to a class? No, it's a classless because you have a CIDR notation. Okay, now listen carefully. If you are given with a CIDR notation, you have to find how many addresses I can allocate using this CIDR notation. Okay, there is a formula. Keep in mind, this is the formula we are going to use. These are not standard methods. These are little shortcuts which you can use to find the answers easily. Okay, if not, what you have to do, you have to write 23 ones. Okay, out of 32 bits, 23 will be ones, others will be zero. You have to put 2 to the power and you have to get the answer. You don't have to know that method. We'll go in this method itself. Okay, so in your IP addresses, you all know what is the total number of bits you have. How many bits you have? 32. 32 minus CIDR notation, you will get an answer which is known as the host bits. Okay, which is known as the host bit. Now listen carefully. Out of 32, what is the CIDR notation here? 23. So what is your host bit? 9. So how to find the number of addresses using this? 2 to the power host bit is equal to number of addresses. 2 to the power host bit is equal to number of address. 2 to the power 9 is equal to how much? 9 is equal to 512. So totally you have 512 addresses. So internet service provider, if they provide you an IP address of 192.168.0.0/23, then how many addresses you will get? How many addresses? 512 addresses. Now, if they give you an IP address like this, 25, then how many addresses you can allocate? Now see, 32 minus 25 is equal to 7. 2 to the power 7 is equal to 128. So totally how many addresses? 128 addresses. Okay, so this is how you find how many addresses are there if they give you a CIDR notation. The basic thing which you have to know doing the subnetting if you want to do the subnetting. How many addresses are there here? 128 addresses. How many addresses are here? 512 addresses. Okay, so I have given the steps in the tute. You can read it later if you forgot this. So go to page number 2 and you have 4 CIDR notation there. Quickly find the number of addresses of them. Got the answers? Got, okay. First one you have CIDR slash 30. 32 minus 30, 2 to the power 2 is equal to 4 addresses. 26, 32 minus 26, 6 to the power 6 is equal to 64 addresses. 29, 32 minus 29 is equal to 3 to the power 3 is equal to 8 addresses. 31, 32 minus 31, 1 to the power 1 is equal to 2 addresses. Okay, that is the concept how you find uh, number of addresses using the CIDR notation. Okay. Hari. So now listen. Now listen. Okay. Is it too cold? Hot? Cold? But by like 11 o'clock again heat will start. So it will be hot again. Can you manage until that? Can't because the remotes are not working. Check with the staff. Staff. Okay, kita kosong di parang. Okay, medicine. Okay. Listen, Hari. So now, as I already told, we as a company go and buy a set of IP address. Once we buy it, we will receive a number of IP address like 1024, 512 or either classful. Anyhow, we are receiving a set of IP addresses, right? Now listen carefully. Now we are going to learn what is subnetting. Okay. Concept of subnetting. It's very simple. Okay, don't make it complex. Subnetting is done in within an internal network. It's not something which is relevant for the external parties. Okay, then මෙන්න මෙහෙමයි. Okay, you go to dialog, you buy a set of IP address. You bring that IP address to your company. Whatever you do with IP address, those IP address, it is not going to affect the dialog company. So subnetting is something which is done for your own purpose. Subnet is something which is done for your own purpose. For example, in your company, you have, imagine like 200 companies. So not 200 companies, 200 computers. Okay. How many computers you have? 200 computers. Now, you want to buy IP address for them. How much IP address you will be given as a power of 2? How much? 256 IP address. Okay, that is the concept we learned. Hari, so now assume in your company there are 4 departments. In your company, how many departments are there? 4 departments are there. Department A, B, C, and D. Okay, department A, B, C, and D. And now in your department A, there are 50 computers. Here there are 50 computers. Here there are 50 computers. And here there are 50 computers. Okay. Now, when you allocate an IP address, imagine you have received the IP address slot of 192.168.0.0. Okay. First IP address you allocate within the department 1, A. Second IP address you allocate it for the department C. Third also you allocate for C. Fourth you allocate for B. Fifth you allocate for D. Like that, you mess up the order and allocate. Is it suitable? Or if not, IP addresses from 1 to 50 into this, 1 to 64 into this, 65 to 127 into this. Like that, in an order, if you allocate, will it be more suitable? Random order or a randomly if you allocate, is it good? Or an orderly method if you allocate, is it good? In an orderly way, if you allocate, it is better. So it will enable a better internal communication within your company. So what you are going to do, as you have 50 computers in this particular department, in order to cover 50, you are giving 64 addresses for this department. In order to cover 50 computers, again you give 64 for this department. To cover 50, you give another 64 here. To cover 50, you give another 64 here. Okay, like that, 0 to 64 to department A. 0 to 63 for department A. 64 to 127 for department B. 128 to 191 for department C. 192 to 255, you are going for the department D. If you give in this order, this will be more suitable inside the company. So you can say if an IP address is within 0 to 63, that belongs to the computer in a department A. Okay, if your address is within 192 to 255, you can say that belongs to a computer which is in the department D. Like that, it will enable you a proper communication. So in order to do this proper communication, once you got an IP address, once you got a set of IP address, allocating it for the several parts of your company by dividing it is known as what? Subnetting. This is the simple concept of subnetting. Receiving a set of IP address, dividing those IP address. Okay, you can divide it equally or unequally. The methods will vary. Okay, you divide it equally or unequally and allocate it for the relevant departments in your company. Will it affect the external network? Will it affect the external network? No. Even if you send from department D, C, B, or A, if a message is being sent, it will recognize it is sent from this particular company only. Internally, to enable a better communication among your company, you divide the received IP address into slots. That is known as subnetting. So, who will do this? In a company, there will be an IT department, there would be a network administrator. He is the person who is going to do this particular process. Okay, he is the person who is going to do this particular process. So what is subnetting? You already know, dividing it into different slots and allocating. So when you are doing this subnetting, you can do it in two ways. You can do it in two ways. One is the method of FLSM and the other one is the method of VLSM. FLSM means fixed length subnet masking. VLSM means variable length subnet masking. Now, what is subnet mask? Okay, so most of the students don't know how to find the subnet mask is easy, but what is subnet mask is somewhat confusing. Okay, so even if you don't know what is subnet mask, you can do the questions, but try to understand the logic of the subnet mask. Okay, the subnet mask is something, subnet mask is something which shows the controllable and the uncontrollable. I forgot the spelling for controllable also. Okay, so controllable and uncontrollable part of a particular IP address. For example, if you have a class C IP address, I told 192.168.10.0, out of this you will get the control of what octet? Only the third octet, sorry, fourth octet. You will get only the control of fourth octet. If you want to allocate it for devices, you can allocate it 1, 2, 3, 4, the last octet only. Can you change this octet? No. Can you change this octet? No. Can you change this octet? No. Hurry. So what does the subnet mask says? The controllable part of the network and the uncontrollable part of the network. The controllable part of the network, it will represent in 0 if it is fully controllable. If it is half controllable, 128. If it is quarter controllable, then 64. I will explain the method how to find it, but just remember controllable parts value will change. 0, 2, 4, 8, 16, like that it can change. But uncontrollable part, if it is fully uncontrollable, we will depict it in 255. Uncontrollable means 255. Controllable means the value may vary. Okay, so now tell me, In this particular IP address, this is a class C IP address. First octet, is it controllable or uncontrollable? So I should write 255. Second octet, uncontrollable. Okay, 255. Third octet, 255. Fourth octet, controllable, so 0. This is how a subnet mask forms. Okay, so if they give you a subnet mask, okay, you can identify, okay, this octet I can't control, this octet I can't control. Like that you will be able to identify. Now see, you have a subnet mask like this. First octet, is it controllable? First octet, will it be controllable? This is a subnet mask, huh? Not an IP address. Okay. So is this part controllable? No. Is this octet controllable? No. This octet, is it controllable? Yes. So you can change the value in the relevant IP address. This octet, is it controllable? Yes. So controllable and uncontrollable part, define kernel, divide kernel, this subnet mask will show. Okay. And if you have like this, okay. Now see, is it controllable? No. Is it controllable? This part? No. This part up to somewhat controllable. Fully controllable mean 0. 192 mean out of 256, 192 you can't control. The remaining 64 you can control. Like that only you have to consider. How to identify controllable, uncontrollable number of devices, I'll explain them. Okay, for now just have the idea. What does the subnet mask gives you? The controllable part and the uncontrollable part of a relevant IP address. Okay, that is what the subnet mask means. Okay, so subnetting can be done in two ways, which is FLSM and VLSM. FLSM means fixed length subnet masking. VLSM means variable length subnet masking. Now see, you have a computer, so you have a company, okay? You have a company. In that company, you have certain departments, A, B, C, and D. A, B, C, and D. Okay. In the first department, you have 30 computers. In the second department, you have, imagine, 35 computers. In the third department, you have like 40. In the fourth department, you have like another 15 computers. Okay. This is the number of computers in each department. Listen carefully. Alright. And then there is another company. Okay, there is another company which is having the same set of computer numbers. A, that is going to be 30, B 35, C 40, and D, that is going to be 50. Okay, so remember, like I'll give just a sample number of addresses. Both of you have been given 256 addresses. Both of you have been given 256 addresses. Now what you are going to do is, you are going to allocate into this departments equally. If you allocate equally, 256 into how much you have to divide? You have to divide it into 4. If you have 5 departments, into how much you have to divide? Not 5. When you are dividing, you have to divide it in the powers of 2 only. You can divide it by 1, 2, 4, 8, 16, like that. 5, 6 can you divide? 7 can you divide? No. In the powers of 2 only you can divide. So, here how many departments are there? 4. Can you divide it into 4? Yes. 256 divided by 4 is how much? 64. Is 64 enough to cover 30? Yes. Is 64 enough to cover 35? Yes. Is 40 cover enough, like 64 enough to cover 40? To cover 15? Yes. If you divide your IP addresses equally and allocate it equally for all the departments, then we call it as what? The FLSM subnetting. Dividing the number of computers equally for the departments and allocating them is known as FLSM. What is VLSM? Allocating based on the requirement. Remember, listen to this carefully. Don't miss the points, but you will get the whole part confused. Okay? Hurry. Allocating based on the requirements. In order to cover 30, how much you will need as a power of 2? 32. In order to cover 35, how much you will need? 64. In order to cover 40, 64. In order to cover 15, 16 is enough. There are other exceptions also. When doing the questions, I'll explain it properly. Okay. So now see, here you divided equally and allocated. That is known as FLSM, fixed length subnet masking. Here you divided it in a variable way according to the requirement. So 32, 64, 64, 16. That is how you got the answer. So this is known as what subnet masking? Variable length subnet masking. So if you divide the number of addresses equally and allocate, that is FLSM. If you divide it in a variable way and allocate, that is VLSM. Understood the difference between VLSM and FLSM? Yes. What are the instances you have to choose FLSM? What are the instances you have to choose VLSM? In the question, if they ask you, use the FLSM method, you are going to use the FLSM method. Listen to this carefully. If they ask you to use VLSM method, definitely you are going to use the VLSM method. But most of the time in the question, they won't say what you have to use. Then which one you are going to use? Is it FLSM or VLSM? FLSM. The first priority should be given to FLSM. You have to check whether using FLSM, can I allocate the devices? Can I allocate the devices? If you can allocate, definitely you have to use FLSM. Whatever the wordings they have mentioned or anything, you have to go with FLSM if you can use FLSM. For example, this is how it is. Okay, can you allocate 64 for all of this? Yes. So can you go with FLSM? Then you should go with FLSM. Here, just for an example, I took like this. You can't go with VLSM in this way if this is the method. Okay, you have to go with what? FLSM only. But for example, I have given when doing the questions, I will exactly say you and how to identify whether it's FLSM or VLSM. Okay, keep it in mind. So before doing the full question, you also need to know how to find the subnet masks. Okay, you also should know how to find subnet mask and the number of addresses as well. Okay, so now before that, write this down quickly. After this, we'll start how to find subnet mask. Online students, you all can hear, right? The video was inverted until now. Were you able to write the notes? Why didn't you all say? You all could have sent, right? The video is inverted. Oh, now okay, right? Okay, 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 okay. Okay. Shh, 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 shh. Listen. So now you have to know how to find the subnet mask of a relevant IP address. Okay. So remember, in your past papers, most of the time, I mean, every time they are testing the subnet mask. If your CIDR notation is /24 or more than that. Hari, listen, don't talk. Hari, if not, if your number of address is 256 or less than that, until now, from 2011 to the 2024 past papers, the questions will be tested based on this range, CIDR notation, 24 or more than that. If not, the number of addresses 256 or less. If it is more than 256 or if the CIDR notation is less than 24, then how you are going to find the IP address? That is the hardest part in this particular unit. Okay, for that we have a separate set of method. First you have to know how to get answers for these, then only you will be able to do those also. Okay, so first understand this clearly. After that, we'll finish the basic questions which would be tested in your exams. And then afterwards, we'll discuss the advanced part of this lesson. Okay, so now listen carefully. If you are getting the CIDR notation which is /24 or more than that, if not, if your number of address is 256 or less than that, your subnet mask last octet will be affected. Last octet of your subnet mask will be affected. Hari, what is the last octet of the subnet mask? You know that 255, 255, 255, 0 is there, right? At the fourth octet, that will be changed. The first three 255, the first three 255 will remain solid. It will be remain constant. It won't change. Okay. In case if your CIDR notation reduces less than 24, then only the change would happen in the third octet. Then sometimes second octet or the first octet. Until that range they won't go. Maximum they would go is the third octet change. But basically everyone should know how the last octet change occurs. So I already told the format of the subnet mask. Uncontrollable means 255, 255, 255. If your CIDR notation is this or more than this, or your number of address is this or less than this, the last octet only going to change. How to find the change that occurs in the last octet? That is what we are going to identify. So now listen carefully. They are giving you an IP address 192.168.10.0/22. They give you an IP, not 22, 25. Okay, they give you an IP address like this. And now they ask you to find what is the subnet mask of this IP address. Remember, subnet mask is something which is very important. You should know how to find the subnet mask. you should know how to find the number of addresses using the subnet mask. Okay, we'll do some sample questions. So now this is the IP address which is being given to you. Classful or classless IP address? Classless IP address. Totally, how many number of addresses are there? 32 minus 25 is equal to 2 to the power 7 is equal to 128. Okay, so if you usually want to find the subnet mask, you have to write the binary of this and do several stuff. Don't do all of those. Okay, simple context is there. In your subnet mask, the minimum you can have is 0. The maximum you can go is 255. Within this range, totally how much value is there? 1 to 255, 255 is there. 0 is also included. So how much you have totally? 256. 256 you have totally. Out of 256, if you have the control of 128 devices, what is the uncontrollable part? 256 minus 128? 128. This should be in the last octet of your subnet mask. Other parts are going to be 255.255.255. Hurry. So at any instances, if they give you an IP address and ask you to find the subnet mask, very simple. First find the number of addresses. 256 minus that number of address. 256 minus that number of address. You will get the answer. That is 255, 255, 255. Last octet is 128. Which means here fully uncontrollable, fully uncontrollable, fully uncontrollable. 128 is uncontrollable. The remaining 128 is the controllable part for you. That is the context. Okay, so now I'll give another IP address. We'll see. Second one, 172.168.10.0 slash we'll see 27 slash 27. They will give you this IP address and ask you find the subnet mask of this IP address. So how you are going to find 32 minus 27 is equal to 2 to the power 5 is equal to 32. Tell me how to find the subnet mask formula. 256 minus number of addresses, which is 32, is equal to 224. 224. Then 255.255.255.224, which means 224 you can't control. Remaining 32 only you can control for the host. That is the context. Sometimes what they will do is they will give you the number of addresses directly. There is an IP address. Okay, listen to the question. There is an IP address which consists of 256 devices or addresses. What is the subnet mask of that address, particular IP address? They won't give you the CIDR notation, but they gave you what? The number of addresses. Tell me the formula. 256 minus number of address, which is 256. So it's going to be 0. So 255.255.255.0. So see, fully uncontrollable, fully uncontrollable, fully uncontrollable. 0 means fully you can control, which is the 256 addresses you can control. Understood how to find the subnet mask? Okay. Sometimes they will give you the reverse of this. They will tell you, question number 5, okay, listen carefully. They will give you a IP address like 192.168.10.0. They will give you an IP address like this. And they will say you the subnet mask of this IP address is with subnet mask. When you are writing subnet mask, the short form you write is SNM. Okay, SM SNM, subnet mask. Okay, so with the subnet mask of 255.255.255.240, they have given you the subnet mask and they have given you the IP addresses. So they will ask you to find the number of addresses. They will ask you to find what? The number of addresses belonging to this IP address. Okay. Now tell me, If the subnet mask is 255.255.255.240, here do we have any controllable parts? Here do we have, here, no. Here do we have a controllable part? Yes. Out of 256, if 240 is not controllable, remaining is how much? 16, which is your controllable number of addresses. That is how you find a simple context. Okay, once more, there is an IP address that is going to be 193.240.0.0 with subnet mask. With subnet mask, we'll take 255.255.255.192. Okay, so out of total 256, how much is not controllable? 192. So remaining how much addresses is controllable? 64 addresses. This is how you find the number of address using subnet mask. So subnet mask is a separate context. What I told to identify the controllable and the uncontrollable part. But in your exam, why do we use this subnet mask is, first question they can ask you from subnet mask is, by giving the CIDR, they will ask you to find the subnet mask. Did you understand that method? Find the number of address, 256 minus that address, you receive the subnet mask. Second question, second type of question, they will give you the number of addresses and ask you to find the subnet mask. Was it clear how to get that? The third type of question they can ask you is, they will give you the subnet mask and ask you to find the number of addresses. They will give you the subnet mask and ask you to find the number of addresses. Was it clear how to get that? 256 minus subnet mask, last octet is number of address. 256 minus number of address is the last octet of the subnet mask. A simple formula, if you remember this, you would be able to do any questions. Was that clear, everyone? Clear? Okay. Just try the question in page number 4. Write this down also. And try the question in page number 4. You have 6 questions. Try all of them. Try all of them. ලයිව් එකටත් හිටියද? සර්වර් සීරීස් එකේ. ඊ එකට හිටියද? ආට කවර් කරගන්න පුළුවන් වුණානේ ඒ ටිකෙන්. ආට තේරුණාද? ඔකම හරි. එයාගෙන් අහන්න තේරුණාද කියලා? තේරුණාද? Do you have any doubts? No, right? Any doubt? Huh?
172, right? The second question.
Yeah.
It's class B, isn't it? It's the network controller, right?
If you have the CIDR notation, that is a classless. Okay. Huh? Range. In a range. Another shape. So, any doubts?
190. That's what it is. Address.
64 address. No. CIDR you don't find like that. CIDR, how do you find 64? You have to write it as a power of 2. 2 to the power 6. So 32 minus 6 will be 26. That only CIDR. You don't have to find the CIDR, but I'll explain how to find it. ඔකම හරිනේ. අවුල්ද? හා? කාටද? තනුලිකෝ අරහෙනේ හිටියේ? ඩවුට් එකක් තියෙනවද? බොරුනේ. මම ළඟට ගිහිල්ලා මම කොහෙද කරන්න හදනවා?
Science.
சலாம் நான் வந்தோன்னு சொன்னாச்சு. எங்க ஆன்சர்?
டைப் பண்ணு
எழுது ஆன்சர் எழுது.
அது முன் துண்டு வரல சார்.
முந்துண்டு தேவையில்லை, இது இப்ப சொல்லி தரேன். இந்த இப்ப ஒரு 5 நிமிஷத்துக்கு மேல சொல்லி தரேன்.
மிஸ் பண்ணுவோமே.
என்ன எப்படி இது இப்பதான் சொல்லி தந்தோம். அங்க பாரு 256 அட்ரஸ் இருக்கு, எழுதியே இருக்கிறேன் போர்டில். என்ன செஞ்சு ஃபோன் ஃபோன் அந்த நேரத்துலேருந்து ஃபோன் பார்த்து வந்து இருக்கிறது.
இல்ல சார்.
அப்படி இல்ல, இந்த இது வந்து என்னண்டே தெரியாட்டியும் பபாவுக்கு சொல்லி கொடுத்தாலும் சரி.
இதா
ஆ?
இது மட்டும் சொல்லிதான் சார்.
மைக் ஓப்பன். Okay, listen. Hurry. Okay, so we'll do the exercises. Did you get the answers? Is it hard? No, right? They're saying it's hard. Easy. Okay, so first one is 256 addresses. We already wrote the answer for that. What is that? 255.255.255.0. Second one, you have 32 addresses. Don't play like small children. Listen, last questions. Give it the mic and I'll ask the questions. Get ready, yeah? Camera. Okay. Okay, so now listen to the context, those who did not understand. Okay. If your CIDR notation is 24 or more than that. If not, if your address is 256 or less than that. Is it less than 256? Yes. So, in the subnet mask, which octet will subject to a change? Last octet. The first three octet, will it be subjected to a change? No. The values are going to be 255, 255, 255. Will it change? No. If your CIDR notation becomes 23, if not, your number of addresses become 512, which is more than 256, then only the subnet mask change will happen in the third octet or second octet. It depends. That method, until now, they haven't tested in the part 2. In MCQ, there are 1 or 2. I'll explain the method to do that also. But for now, as we are focused on the part 2 question, you all can see we are going to give you number of addresses or CIDR notation which is less than 24, sorry, less than 256. If not, CIDR which is more than 24. So the octet change will occur only the last octet. Okay. So here the default subnet mask is like 0 to 255, no? So totally you have 256 addresses. So you can see out of 256, if you have 32 addresses, the uncontrollable part will be how much? 224. Okay, subtraction, is it hard? No, right? Okay, just subtract and get the value. First three octet will, however, be 255, 255, 255 dot 224. This will be the answer. Is it hard? No. Online students understood. They are the ones who said this is hard. Okay. So next you have 64 addresses. Next you have 64 addresses. Tell me 64 addresses, is it less than 256? So which octet will change? Last octet. So out of 256, if you can have 64 addresses, what is the uncontrollable part of this? 192. So 255.255.255.192. That is the answer. Okay, that is how you do it. Next one, 192.255.0.0/29. You don't have to consider about the IP address, just consider about the CIDR notation, 29. Is it more than 24? Yes, 24 or more mean the octet change will happen in the last octet. So you have to find the number of addresses. How to find the number of addresses? 32 minus 29. Answer is going to be 3. 2 to the power 3 is equal to 8. So 255.255.255.256 minus 8, 248 will be the answer. Got it? Okay. So what is the answer for the next question? 27. 27 means 32 address, subnet mask will be 224 at the last. Okay. Sixth one, 30. So 2 to the power 4. That's going to be 2 to the 30, 2 to the power 2 is 4. So 256 minus 4. Answer will be 258. 2. Okay, 252, the last octet chain. Okay, that is how you identify them. Alright. And then there's other small method. I already explained that using the subnet mask, if you want to find the number of addresses, you can use the relevant method. Okay. Next, you have an exercise fully. First one, I will explain it with everything which you need to know. And the other question you will have to try. Okay. Now look at the board carefully. Okay. 1 minute. If you get a small 1 minute break itself, start talking. Listen, listen. Don't talk. Hurry. So now see the exercise. Consider the following scenario. Okay, these type of question, will it be definitely tested? Yes, every year from 2011 until the last year paper, with this year paper also, this will be tested. Okay, so nowadays the marks which is allocated for this particular part is very few. Like 3 marks only will be allocated out of 100 for this particular question. But until 2021-2020 paper, like 7.5 marks was allocated for this particular question only out of 100 marks. But now, as the weightage is being increased, the marks which is allocated for this is reduced. So now it's a less important question, but still you will have to know this, then only you can do MCQs related to the networking as well. Okay, so listen carefully. Consider the following scenario. A food production company has 4 LANs. What does 4 LANs mean? LANs, local area network. You all learned it in the theory, right? Okay. And then for each department, such as accounting, information system, marketing, sales, production, the table given below shows the number of computers and the network printers in each department. Okay. And they have given, like most of the time, okay, follow the steps. Everything which you have to know here is very important. Sometimes what you see, the above question, consider the following scenario, something they have given about the company, you just ignore it and move on to the table. But don't do that mistake every time. Read the top part also, because some important things which you could miss would be included in that particular part. Okay, so in this question, there is nothing. Hurry. So they have given the table, department, number of computers, number of network printers. Okay, so we'll talk about a department. A department is a local area network. A department is a local area network. Hare, in a particular department, you will have a switch or hub and you will be connecting computers for this particular department. Okay. Hare. So now in the accounting department, like this, how many computers have been allocated? How many computers have been allocated? 33. What is a network printer? I explained that day in the theory class. What is a network printer? A printer that is connected to a switch or the network. So a printer, if it is connected directly for the network, which is the central device, hub or switch or a router, then that will be network printer. Do we have to allocate an IP address for that also? Do we have to allocate? Yes, you have to allocate an IP address for the network printer. If it is a normal printer, do we allocate? If it is a normal printer, do we allocate? No, only for the network printers. For the other computers, do we need IP addresses? Yes, we will need an IP address. Okay. So if you take the context of a particular LAN, this is a LAN. In the accounting department, which is a LAN, you have 33 computers and number of network printers, you have 1. So totally how many devices are there? 34. Out of 34 devices, how many IP addresses you will need? You will need for all the 33 computers and for the network printers. So totally, what is the required number of IP addresses? 34. But there is one exception. Listen, if you have a local area network, all the messages which are entering to your network should come to the switch. Should come to the switch. So, in order to receive the messages, you will need one IP address. In order to receive the messages into your network, you will need one IP address. Okay, one IP. That IP, we call it as what? Network IP address. Okay. In order to send the messages from the department to the other department from the switch, you will need one more IP address. That we call it as what? That IP address we call it as broadcast address. So why do we use a network address? It is the first IP address of a network. Okay, in a particular local area network, the first IP address is what? First IP address is network address. What is the purpose? To receive messages into the network. And the last IP address of a network is the broadcast address. The last IP address of a network is the broadcast address. Why do we use it? To send the informations and data out of the network to the other departments. Okay. So in a network, if you have 33 computers, you will need 33 IP addresses. If you have one network printer plus one, you will need 34 IP addresses. Whatever the number of addresses you are having, definitely you should have two more IP address, one for the network address, other one for the broadcast address. First address should be allocated for the network address, last address should be allocated for the broadcast address. First address is known as network and last address is broadcast. Network address is used to receive data into the network. Last address is known as broadcast address is used to send data out of the network. Okay, remember that concept. So here you had 34 computers, then definitely you will need an extra two IP address, one for the network address and other one for the broadcast address. Okay, listen carefully. Again and again, don't ask why did I add this two? Why did I add this two? For broadcast and network address. Okay, so totally what is the required number of IP address? 36. Okay, remember that context. So every time you don't have to write this and see, using your mind, you can calculate. Accounting department 33 plus 1 plus 2, answer is 36. You will need 36 IP address. Marketing department 37. Bomb, bomb. Okay, so marketing department, you have 37 computers and one for the network printer, so 38, and then two for the network and broadcast. That is going to be total of a 40 IP address you will need. Okay, so keep that aside. Okay, keep that aside for now. Read the below description. An IP block 192.147.1.0/24 has been assigned to a network administrator. The network administrator must assign IP addresses to all the nodes in each department. Four subnets will be set up for this purpose, and this network will be connected to a public IP address for internet access of employees. Each department is located in a different building. A firewall is installed for the security of the network. For switch, necessary network cables, proxy server, and the DHCP server are provided for the network administrator for this purpose. The accounting information system department is directly connected to the internet. A ලොකු description එකක් දීලා තියෙනවා. What is the purpose of this description? Why? Why they have given? This is not needed to fill this table. But why they have given? Then why? To draw the network diagram. Mark that particular description and keep for the purpose of network diagram. If not, after reading that, you will confuse what you have to do with that in the table. That particular part is relevant for the network diagram. Mark it down. Okay, so now what is the IP address they have given for us? 192.147.1.0/24. To which class does it belong to? Classless. CIDR mean it's classless, not a class C IP address. Okay. Remember that in MCQ they will give a question like this and ask you into which class does it belong to? This belongs to the C class. True or false statement they will give. Don't be so dumb. It's classless. Okay. CIDR notation have classless. CIDR notation no, then classful. Okay. Alright. So now listen carefully. See the last octet. See the last octet. If it is a zero, what you are going to do? Start with zero. If it is a zero, start with zero. If it is not zero, if it is any other number, listen carefully. If it is any other number, find the starting address. Find the starting address. These steps definitely all should know. Okay. So this is, I think, the 2020 past paper question. So like this, you will in the past papers from 2011 to 2022 paper, this last octet was 0. So you can directly start with 0. You don't have to worry. But here, if they give a number like 30, 40, 32, 64, then you can't start with 0, neither you can't start with the given number. You will have to find the starting address. How to find them, I'll tell and give. But for now, 192.147.1.0 is the last octet 0. So can we start with 0? Yes. So I'm going to start the accounting department with that particular IP address. 192.147.1.0. I have to start. Just write the network address and I kept. Now, in the question, anywhere did they mention whether I have to use FLSM or VLSM? Did they mention? No, they did not mention. Then what I have to do? I have to check whether I can use FLSM or should I use VLSM. How do I check that? Listen, /24 means how many addresses I have? 32 minus 24 is equal to 8 to the power 8 is equal to 256. How many departments do I have? How many departments? 4 departments. 256 divided by 4, totally 64 per department. What was it? Was it a sound from the speaker? Someone's phone? Okay. So, listen. 64 addresses per department. Accounting department, listen. Accounting department, 64 addresses, is it enough to cover all the requirement? Accounting department, yes. Marketing department, yes. Sales department, is it enough? 64, enough. Production department, is it enough? 64 is enough. Then, if you use FLSM, can you allocate for all the department? So do we have to think about VLSM? No. If can't, only have to go for VLSM. In this question, do we have to go for VLSM? No. You have to go only for FLSM. Okay. So now listen carefully. Accounting department 192.147.1.0. Okay. How many addresses you are going to allocate for the accounting department? I'll just put it here. 64, 64, 64, 64. Okay. If your first address is 192.147.1.0, if you want to have 64 addresses, what should be your last address? 63. 63. Okay, remember that. Because if you count from 1 to 64, then the last address will be 64. But if you count from 0, because here 0 is 0, but it has a value. So 0, 1, 2, 3, if you count, If you want to go for 64, if you count until 64, it should end with 63. Okay, so the last address is going to be 192.147.1.63. Other things we'll see later. If this stops with 63, this should start with 64. 192.147.1.64. 64, if you go another 64, that should stop by 127, not 8. Why? 65, 66, 67. If you go like that, then you will stop by 128. But here you are going to include 64 also. 64, 65, 66. Like that, if you go, when you count another 64, you will stop by 127. If you get the logic, that's the good thing. Okay, if you don't get the logic, just add 64, subtract 1 and put 64 plus 64, 128 minus 1, 127. Okay. 192.147.1.127. If this stops by 127, this should start by 192.147.1.128. 128 plus 64 minus 1, 192.147.1.191. This should start with 192.147.1.192. 192 plus another 64 minus 1, 147.1.255. Was it clear? Very easy. Just adding 64 and what? Okay. 0 plus 64, 64 plus 64, 128 plus 64, 192 plus 64, minus, 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 minus 1. Okay, that's it. Okay. So now you have to find the subnet mask and the usable range. Subnet mask is also easy. First, we'll find the usable range. Okay, what is this usable range? The range in between the network and broadcast is the usable range. If you take a particular department, network address and broadcast address, can you use it for the devices? Can't. It is a fixed first address and a fixed last address. So the usable range should be in between network and broadcast. Then only you can use it for the computers, network printers, or the other devices you have. So what is the network address range between, what is the address range between network address and the broadcast? 192.147.1. 0 between 0 and 63, what do you have? 1 to 192.147.1.62. Here it's going to be 192.147.1.65 to 192.147.1.127 එකට අඩු කරන්න 126. Then it is going to be 192.147.1.129 to 192.147.1.190. And then the last one, it's going to be 192.147.1.193 to 192.147.1.254. Okay, the numbers in between this range 0, 63, what is in between? 162, 1 to 62. 64, 127, what is in between? 65 to 126. 128, 191, 129 to 190, 190 to 255, 191 to 254 is the in between range. Okay, understood that part? That is how you find the usable range. When you are writing the usable range, do we have to write the full address like this, or just can we write like this? මෙන්න මෙහෙම ලියන්න පුළුවන්ද? You have to write the full address. Okay, wherever you are writing in this particular table, every part should contain the full address. If you, for laziness, if you write only the last number, that will be an mistake. Okay, that will be a wrong. Okay, not a correct answer. So full address තිබ්බම විතරයි they will be giving the marks. Keep in mind. Okay, and now we'll find the subnet mask. Okay, subnet mask find කරන්න you can either use the CIDR notation, or if not, you can use the number of addresses. For this particular department, okay, what is the CIDR notation? So 24 address is 256. So subnet mask is 256 minus 256 equals 0. So 255.255.255.0. Is this the subnet mask of the department or subnet mask of the subnet? Subnet mask of the department. For your department, sorry, not subnet mask of the relevant whole company. Okay, for your company, they gave this IP address, right? They gave this IP address. The subnet mask of this company is 255.255.255.0. But did you exactly allocate the same number of IP address here for the subnets, or did you divide it and allocate it? Divided. For the whole network, you had 256 addresses. But for one subnet, you have only 64 addresses. So this subnet mask, can you go and write it there? No. For that, you have to find the relevant subnet mask for that particular department. Okay. So department, which is accounting, uses how many addresses? 64 addresses. It uses 64 addresses, means 256 minus 64, then answer is going to be 192. Subnet mask should be 255.255.192. Here also same. Do we have to calculate it again? No, you already calculated, right? Write it down. 255.255.192. Here also same. Here also same. 192. So in FLSM, don't write, wait. In FLSM, will the number of addresses change from department to department? No. So will the subnet mask change? No. So in FLSM, you will have fixed length subnet mask. That's what we call it as a fixed length subnet masking. You can see equal number of subnet mask. But in VLSM, this might change. Okay. We'll do a VLSM related question as well. So was this part clear, everyone? How to identify the network starting address? If it is 0, just put it. If not, you have to find it. Here it's 0, so you just put it. 64 addresses per department, broadcast, usable, and the subnet mask. All clear? All clear? Okay. So write it down quickly. Okay. Go to the next question. Question number 6. Not question number 6, page number 6. Okay, listen. So in this particular question, don't talk. A medium-sized garment factory has lands for each department, such as business, information system, accounting, production, and marketing. The table given below shows the number of machines in each department. So that is the table. Accounting department, 19, number of network printers, 2. So you have marketing, 40, sales, 10 plus 1, production, 12 plus 1. So totally these are the number of computers, don't talk, number of computers, and these are the number of network printers. Apart from these two, definitely we will require another 2 IP address. For what purpose? Network and broadcast. So total number of address needed for accounting department, 19 plus 2 plus 2, 20, 40 plus 1 plus 2, 10 plus 1 plus 2, 12 plus 1 plus 2, 50. Okay, so these are the requirements you have been required. Okay. So now the network administrator has provided with an IP block. They have given the IP address. Okay. The network administrator should assign IP address for each node in each department. 4 subnets are to be made for this purpose. Moreover, and those things they have given. So as I told, that particular description is relevant for the network diagram. Okay. Now they're asking the first question, then they have asked another question, and then third question only they have asked the table. So first we'll see how to answer the question number 1 and the question number 2. What is the first question? The subnet mask of the following network. They still did not talk about the subnet. They're talking about the network. How to find the subnet mask? Tell me. How to find the subnet mask of this network? 32 minus 25 equal to 2 to the power 7 is equal to, and then 128 is equal to 128. So what is the subnet mask? Dot 128. Okay, that is the subnet mask of the table. How many addresses are available? You already found. But how many addresses are available? 128 addresses are available. Then they have given the table. We'll see the table. Department, they have given accounting, marketing, sales, production. They have given network address, broadcast address, subnet mask, and the usable range. Okay, now listen carefully. There are 2 important things which you have to note about this particular question. Online students, you all can hear, right? Okay. Hurry. Now, see the IP address which has been given to you, that is 192.146.1.130. You have a CIDR notation, then it is a classless. When finding the subnet mask, you find using the CIDR notation, right? So what 255.255.255.128 is the subnet mask. You don't have to consider class A, B, or C. Okay, class A, B, C will be decided if you don't have the CIDR notation. If you have a CIDR notation, that is definitely a classless IP address because CIDR stands for classless interdomain routing. Okay, Hari. So now, how many addresses are available in this network? 128. How many departments are there? 4 departments. So for each department, oh, wait. So they have asked, they haven't told whether you have to use FLSM or VLSM, right? So we have to find. So first I'm going to check whether I can use FLSM. So 128 I should divide by 4. So for per department I can allocate 32. Now listen carefully. Earlier I got 64. 64, was it enough for all the department? Yes. Now I have got how much? 32. Come here, see, A needs 23. Is 32 enough? Yes. M, which is marketing, needs 43. Is it enough? 32, is it enough? No. So, can you use the FLSM method? Then you have to move to VLSM. If you can't use FLSM only, you are going to move to VLSM. That is the context. Was that clear? Was it clear? If you use FLSM per department, how many addresses you can allocate? How many departments, so how many addresses you can allocate? How much? Huh? How much we can allocate? Which question? Okay. So I have a total of 128 addresses. Okay. If you all don't understand, at least give a reaction like you didn't understand. Don't act like you understood. Okay. 128. Okay. How many departments you have? 4 departments. If you are using FLSM, should we use equally or inequally? Inequally. Equally. දෙකටම මේ කරනවා. Equally or inequally? Equally. So you have to divide it by 4. Why divide by 4? Because there are 4 departments. So if you divide it by 4 per department, you will get how many addresses? 32. Is 32 enough to cover the accounting department? No. Yes. Marketing department, is it enough? No. Why is it not enough? Because you have 43 computers, 32 is not sufficient. So can you use the FLSM method? Can you use? No. If you can't use FLSM, what is the method you have to use? VLSM. VLSM means you have to allocate as a power of 2. Okay. So now you can't use FLSM. Leave that topic. You can't. 32 is not enough. Okay. Now see in the power of 2. If you want to allocate addresses for 23 computers as a power of 2, how much is enough to cover 23? 32. To cover 43, how much is needed? To cover 13, how much is needed? To cover 15, 16 is needed. Add them and see the total. 32, 32, 64, 64 plus 64, 128 you will get. It could be 128 or less. Okay. Total, if you add and see, sometimes it could be equal to the number of addresses that is available. Sometimes it could be less than that also. But can it go more than? You can't go more than. Okay, it should be less. Okay, if it goes more than, there will be an error in the question. Okay, there was one past paper question. In the past paper question, there was an error in the CIDR notation. They gave free mark. Sorry. So this is how the context goes. Now, you found the requirements you are going to allocate for each department. In the table, you have to draw the table in the answer scheme, right? In the table, you have to mark it down. Okay, here, it's not mandatory for your own purpose. Accounting department, how many IP addresses I allocated? How much? For the marketing, how much I allocated? For this one, sales. For the other production, 16. Okay, just mark it and keep. Okay, now see the given address 192.146.1.130. Listen to this very carefully. 130. I told two things earlier. If it is 0, start with 0. Start with 0. If it is any other number, find the starting address. Find the starting address. Okay, find the starting address. Okay. So here, are you going to start with 0 or are you going to find the starting address? You're going to find the starting address because it's not starting with 0. How do you find the starting address? How we are going to find the starting address? Listen carefully. You have to get the last octet of subnet mask. You have to get the last octet of subnet mask. You have to AND operate it by last octet of given IP. Given IP. Okay, that is the formula. I'll explain how to do. Okay, so why did I use this formula? Because my given address, the last octet, did not start with 0. If it start with 0, do I have to find like this? No, I can directly use the 0. But here, what is the number they have given? 130. If it is any other number apart from 0, I have to find the starting address. So how to find the starting address? The formula is the last octet minus the last octet AND operated by last octet of subnet mask AND operated by last octet of given IP. Okay, what is the last octet of the subnet mask? Last octet of the subnet mask? 128. What is the last octet of the given IP? 130. Can you AND operate two numbers using decimal values? AND operate two numbers using decimal values. You have to convert it into binary. You have to convert it into binary. Listen very carefully. What is the binary of 128? It's going to be 1, 2, 4, 8, 16, 32, 64, 128. What is the binary of 130? That is going to be 10000010. Okay, 130's binary is this, 128's binary is this. You all know how to convert to binary, right? You all know, right? If not, that's the problem. You have to perform AND operation between them. How to perform AND operation? 0 and 0. 0.0 is the answer. 1.0, 0.0, here, here, and here, 1. You got this answer. Convert it into decimal. What is this answer? 128. So this is your starting IP. This is your starting IP. Okay, understood. Understood. Okay. If your given IP address did not start with 0, you have to find the IP address, starting IP address. What is the formula? What is the formula? Last octet of the subnet mask AND operated by last octet of the given IP. What was the last octet of given IP? 130. What was the last octet of the subnet mask? 128. In order to perform AND operation, you have to convert both of them into binary. If you perform the AND operation between them, you get the answer as 128. So now your starting address is going to be, what is the starting address? 192.146.146.1.128. Understood that concept? If you started with 0, what will happen? The whole question will become wrong. If you started with 130, what will happen? Whole question is still wrong. You should start it with 128. Was it clear? Okay. I'll ask someone to come to the board and do. Okay. So now, listen. 192.146.1.128. How many addresses you have allocated? 32. From 128, if you go another 32, what will be the answer? 192.146.1 dot 128 plus 32, 100 and what should be the answer? 1. What is the answer? 100 and you have to minus 1. Then 159. You're not telling the answer properly. Add and say 32, right? Okay, add it. What will be the answer here? 160. If you deduct 1, what will, don't talk. If you deduct 1, what will be the answer? 159. If this ends with 159, this should start with 192.146.1 dot 160. 160 plus another 64. 192.146.1 dot, okay, 160, you have to add another 64, then answer will be 42224 minus 1 will be 223. 223. If this is 223, this should start with 224. So 192.146.1 dot 224. 224 plus another 16. Okay. 224 plus 16. What will be the answer? Then here 3, 4. Here it's going to be 2 minus 1. That's going to be 192.146.1 dot 239. Then here it should start with 192.146.1 dot 240 plus 16. That is going to be 256 minus 1. 192.146.1 dot 255. Okay, this is how your range goes. Okay, so after this you have to find the usable range. Okay, usable range is the range in between the network address and the broadcast address. So it's going to be 192.146.1 dot 129 to 192.146.1 dot 158. Here it's going to be, I'll write only the last octet. Here it's going to be 161 to 222. Here it's going to be 225 to 238. Here 241 to 254. Like that, the usable ranges will come. Whatever in between the network address and the broadcast address is what is considered as the usable range. Okay. Then you are going to find the subnet mask. In fixed length method, FLSM, your subnet mask was similar for all the 4 departments. But here will it be similar? No. Why? The number of addresses for each department is changing. So the first department, accounting, 255.255.255.256 minus 32. 256 minus 32, 224. 255.255.255. How many addresses are here? 256 minus 64, 192. So answer should be 192. Here 1255.255.255.16. So 256 minus 16, 256 minus 16, 240. So answer is going to be 240. So here also 16 of same answer, 255.255.255.240. Got it? Is it hard? No, right? Not hard. Okay. So most of the time in your exam, they won't give you to find the starting address. It's most of the time it's 0. Only in the 23 paper they gave the another like 32 or something in the 23 paper they gave. In some other term test papers also they gave another number. In those instances you had to find it, but most of the time it will be 0. If it is 0, you can directly start with 0. If it is not 0, find the starting address and then do the sum. Okay, got it? Clear? Okay, write this down quickly. Okay. Wrote it down. Okay. So next we'll be starting the uh, other one, the advanced part of this. Okay, you all seem so dead, you all need a break. Okay, in seminars, usually we don't give breaks. Oh, okay. Oh, okay. Okay, so take a small, not small break. That will be the only break you will get. Now the time is 12:15. By 12:45, you all should be here. Ah, enough. Eat. Yeah, okay. Eating, 5, 6 minutes is enough to eat. Don't go and eat rice. Just buy some snack and eat and come. Snack. You don't have to eat rice. Uh, Unknown students, the class will again start by 12:45. If there is any delay in the physical students coming here, it could be take like 1 o'clock. Okay. You all also can leave the meeting and join by 12:45 again.
Check.
Online students, you all can hear me, right? Okay. Sorry, listen. So now we have to move for the other part where the subnet mask change could occur in the third octet. Okay, where the subnet mask change could occur in the third octet, and how to do them easily we will be seeing. Okay, so listen carefully. Okay, listen carefully. If your CIDR notation, okay, what is CIDR notation? The CIDR notation depends on the number of bits you are using for the network. Okay, so if your CIDR notation is /24, into which octet it is fallen? Fourth octet. So that's why, okay, if your CIDR notation is /24 or more than that, the octet change will happen in the last octet, in the subnet mask. If your CIDR is /23, in your subnet mask, where the change should happen? Third octet. If your CIDR notation is /17, where the octet change should happen? Huh? Third octet still. If your subnet mask change is going to happen, sorry, if your CIDR is going to be like /10, in your subnet mask, where the change should occur? In the second octet. Like that only you decide what is the subnet mask, what is the change that is going to happen in the subnet mask. Okay, so most of the time you are not going to get the subnet mask change which is going to happen in the second or first octet. It's most of the time it's fourth octet. That method we already learned, but there are chances that they could test the third octet subnet mask changes as well. If that is so, how to find the subnet mask, how to find the number of addresses, that is what we are going to see. Okay, so here I'll take an example. Your CIDR notation, listen carefully. Your CIDR notation of an IP address is going to be 192.168.1.0/23. Okay, so what is the CIDR notation? What is the CIDR notation here? /23, which means the subnet mask change is going to occur in which octet? Which octet? third octet. Why 23 belongs to third octet? Okay, how does it belong? You just have to count and see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Like that, 23 comes here, so it will fall under the third octet change. Okay, Hari. You have to start counting from 0. Okay, Hari. So now your CIDR is /23. So the subnet mask is going to change in the third octet. But how do you find that particular change? That is what you are going to see now. Okay, first what you are going to do, take 32. Take 32, subtract 23 from it. You will get the host bits. What is the host bit? What is the host bit? Host bit is equal to 9. Host bit is equal to 9. So represent 2 to the power 9. Okay, represent 2 to the power 9. So from this, listen carefully, from this 2 to the power 9, you have to remove whatever belongs to the fourth octet. Out of 9, how many bits belong to the fourth octet? 8 bit belongs to the fourth octet. So you are going to remove whatever belongs to the fourth octet. You have to divide if you want to remove in the power. Okay, remove 2 to the power 8. Because when you find the change that is occurring in the third octet, can we consider the fourth octet here? Can't. So you have to remove that element. Okay, you have to remove that element. So 2 to the power 9 divided by 2 to the power 8 is going to be 2 to the power 1. 2 to the power 1 is equal to 2. So now take this 256 minus 2, the same method. What is the answer? 254. But now your subnet mask change should happen in which octet? Third octet. 255, 255, 254.0. Okay, here 0 should come. Don't put 255. Without a number becoming 255, the other octet can't become 255. So here it didn't become 255, right? So you can't put 255 here. That should be 0. Okay, honey. Now I'll give another example. 192.168.1.0/20. I have to find the subnet mask. Listen carefully. First, what I have to do, find the host. 32 minus 20 is equal to 12. 2 to the power 12 belongs to third octet. No. Okay, 2/20 means third octet. So for the fourth octet, I have to remove how much? 2 to the power 8. So if I remove it, 2 to the power how much? 2 to the power 4. 2 to the power 4 is equal to, okay, 256 minus 16, 240. This belongs to which octet? Third octet. 255.255.240.0. Very easy. If they give you the number of address, for example, they are giving you like this. There is an IP address that is 192.168.1.0. In this particular IP address, number of address is going to be how much? Number of address is going to be 1024. Okay, number of address is going to be 1024. If you have 1024 addresses, write it as a power of 2. 2 to the power how much is 1024? 2 to the power 10. 2 to the power 10. Now do as usual. Remove 2 to the power 8 is equal to 2 to the power 2 is equal to 4. 256 minus 4 is equal to 252. Answer is going to be 255.255.252.0. That is how the context goes. Was that part clear? Very easy. You just have to remember the step. Now I'll do one more. 1.0.0.0 slash. Now I'm going to take the CIDR notation as what? CIDR notation as slash, we'll see like 13/13. Okay, CIDR notation is /13. Subnet mask change should happen in which octet? In the second octet. Okay, this is an extra one. Now, if you need, just listen. Okay, 32 minus 13. What is the answer? What is the answer? What is the answer? 32 minus, 32 minus 13. 19. 19. Okay. So now listen carefully. 2 to the power 19, but how much you have to remove? 2 to the power 16. What is the reason? Here you had to make the change in the third octet. So you removed what was belonging for the fourth octet. Here you are going to make the change in the second octet. So you have to remove whatever belongs to the third and the fourth octet, which means 8 plus 8, 16. Okay, then 2 to the power 19 minus 2 to the power 16 is equal to 2 to the power 3. 2 to the power 3 is equal to 8. 256 minus 8 is equal to 248. So answer should be 255.248.0.0. Understood? That is how you should do. If you use this method, any subnet mask change, you will be able to find up easily. Okay. Note down this quickly and try the exercise number, exercise in page number 7 and page number 8. Online students, yeah. Here, what you will have to do is, if you I had some doubt questions also. How did I get that 2 to the power 8? That is the 8 bit which belong to the fourth octet. Okay, when you are doing something related to the third octet, you have to remove what belongs to the fourth octet. So which is 2 to the power 8, right? So in the fourth octet, you have 8 bits. So you remove that 2 to the power 8 and then you calculate it, you calculate the value 256 minus that particular value and put it in the third octet. In the last one, what I have done is, I have made a change in the second octet, which means slash 13 it belongs to the second octet. Okay, so I had removed 16, which means I have removed what belongs to the third and the fourth octet, which is totally 2 to the power 16. Okay, and then I got the value and inserted it into the second octet of the subnet mask. Okay, so again, once more. Bhagata hour, then okay, listen. Now you have an IP address. I'll point out and ask you, 192.205.100.0/20. How do you identify in which octet the change is going to happen? Okay. If your CIDR notation is 0 to 7, in which octet it should change? If your CIDR is /18 to 15, 16 to 23 means 24 to 31 means /20. In which octet the change should happen? Okay, in the third octet the change should happen. So first get the host bit. 32 minus 20 is equal to how much? 12. Write this as a power of 2. 2 to the power 12. In which octet the change is going to happen? In the tell third octet. In the third octet. Then you have to remove whatever belongs to the fourth octet. You have to remove whatever belongs to the fourth octet if you want to find the change that is going to happen in the third octet. What belongs to the fourth octet? What belongs to the fourth octet? 1, 2, 3, 4, 5, 6, 7, 8. What belongs to the fourth octet? 8 bits. So from 2 to the power 12, how much you have to remove? 2 to the power 8. But to remove, why didn't I put minus? Why did I put division? Because if you want to remove something from the power, you have to put division. If you want to add something to the power, you have to multiply. You all know that, right? There's a grade 6 maths class also. Okay. So 2 to the power, how much is remaining? 2 to the power, how much is remaining? 4. 2 to the power 4 is equal to how much? 16. 2 to the power 4 is equal to 16. What is the formula to find the subnet mask? 256 minus 16. 256 minus 16 is equal to 240. You should insert this in which octet? Third octet. So the first two octet should be what? 255, 240.0. Now did you all understand why did I remove this to the power 8? Understood? Understood? Okay. So next question, I'll take like this. We'll go with 15. Okay, /15. If your CIDR notation is /15, in which octet the change should happen? Second octet. Okay, so 32 minus 15. What is the answer? 17. Write it as 2 to the power 17. You have to remove whatever belongs to the change happens in second octet mean you have to remove whatever belongs to the third and fourth octet. What belongs to the third octet? What belongs to the fourth octet? Totally how many octets? Totally how many bits? 16 bits. So remove that 16 bits, 2 to the power 16. That is going to be 2 to the power 1 is 2. So 256 minus 2, 254. This should be inserted in the 0.0. Clear? Clear? Tirunada. Hari. That is how you do it. Okay. Yeah, the question is 19, but I just did an example. Okay, now. Okay, listen to this. Listen to this. Now your IP address has, okay, now your IP address has 2048 addresses. They did not give the CIDR notation. So first identify the power, 2 to the power, how much is 2048? 11. From 11, in which octet the change is going to happen? Are you going to see the CIDR 11? No, no. Okay, how you are going to see? You are going to see the bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because it's 2 to the power host bit. You have to count from this side. Now in which octet the change is going to happen? Third octet. So you have to remove all the things related to the fourth octet, which is 2 to the power. 2 to the power. How much? 2 to the power 3 is 8. 256 minus 8. 248, 255 dot, 255 dot, 248 dot 0. Got it, got it, got it. Okay, hurry. Done with the exercise. Now do, boys, do. Understood? Okay. Shh, 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 shh. Listen. Don't talk. Hurry. So, in case if they ask you to find the number of addresses by giving you the subnet mask, and if the subnet mask change happens in the third octet, how you are going to find it? Okay, listen carefully. In the fourth octet, how did you find 255, 255, 255, 128? How did you find this? 256 minus 128 is equal to 128 addresses. That is how you find for the last octet. But now change happens in the third octet. Okay, listen very carefully. 256 minus, what is the change? 248. So answer is 8. Write 8 as a power of 2 to the power 3. For this particular octet, how much belongs? When you calculate the host, you have to include that also, right? So multiply by 2 to the power, totally 2 to the power 11 means 2048 addresses. Anything you can do using this method. But the thing is, don't confuse the methods with each other. You will mess up everything. Logically understand and keep. Okay. Next one. Listen. If your subnet mask is 255.255 dot, let's say 252.0. 252.0. Tell me the method. 256 minus 252 is equal to 4. 2 to the power 2 is equal to 4. Multiply by 2 to the power 8. 2 to the power 8 is equal to 2 to the power 8 into 2 to the power 10 is 2 to the power, okay, 10,024 addresses. That is a simple method. In case if they ask you, you should be able to find it. Okay, understood? Okay, note that down and write the answer for that question also. Page number 9, do that. All of a sudden, I got a confusion. How comes 8 binaries? 8. Why? Why not? If you convert all the 8 ones into binary, answer will be 255.
Bluetooth off करना gimbal का
Huh? I asked to do. Say yes or no. இது முதல்ல செய்ய சொன்னேன்.
இது எனக்கு செய்ய தெரியாது.
டூ த பவர்ல ரெப்ரசென்ட் பண்ணி 8 ரெடியூஸ் பண்ணி 25 ரெடியூஸ் பண்ணி போடுங்க செகண்ட் ஒன்.
இது 2 to power கண்டுபிடிச்சு அப்படின்னா இது 2 to power 10. 2 to power 10 minus 2 to power 8. இல்ல இப்ப எனக்கு டவுட் இருக்கு. இது வந்து தேர்ட் எப்படி அவனுக்கு தெரியும் இது தேர்ட் இருந்து
2 த பவர் எத்தனை?
2 to power 10.
அந்த 0 பின்னுக்கு என்ன கவுண்ட் பண்ணிக்கணும் வாங்க. பின்னுக்கு என்ன கவுண்ட் பண்ணும்?
அப்ப 2 to power 10 இருந்தா இங்க வரும்.
தேர்ட் ஆக்டர்ல சேஞ்ச் ஆகும்.
இப்ப இது வந்து இது ஒரு 7 7 8 வருது 5 2
2 த பவர் 9.
9. அப்ப அதுவும் தேர்ட்.
அதை நான் டிவைட் பண்ண அது செய்யவே இல்லையே. அது வேற ஸ்லாஷ் 15. Okay, so we'll do the last question in the tune. You have the last question, which is like related to a different kind of subnetting. So listen to it carefully. So CSK company has got an CSK company has got an IP address of 172.168.222.0/23. Okay, what is the IP address they have given? Two dot 168 dot okay, so this is the don't talk. This is the IP address they have given. So tell me how many addresses are there in this table in this particular IP address? 9 2 to the power 9 is equal to 512 addresses are there. Okay, and then if they ask you the subnet mask of this, how you are going to find the change should happen in which octet? Change should happen in which octet? Third octet. Which octet? Third octet. So 2 to the power 9, you have to remove what belongs to the fourth octet, that is 2 to the power they are in a different world. How much you have to remove from 2 to the power? You. Yeah, yes, you. 8. 2 to the power 8 is equal to how much? 2 to the power 1 is equal to 256 minus is equal to 254. This should be inserted in which octet? Which octet? Third octet. What you all ate for lunch? 255, 255, 254.0. Okay, that is a subnet mask. Okay. Now we'll see what they are asking. Hari. Now these are the basic thing which you should find for any question. Hari. Now read the question number 1. State the network address and the broadcast address of the given IP address block. Last octet is 0. Okay, you have to check the third octet also, but that will be very confusing. For now, just remember starting address is the given address itself. 172.168.222.0. Okay, listen to this very carefully. They are asking the network address and the broadcast address of the given address block. What is the number of addresses you have in this particular block? How many addresses are there? 512. Okay. So if you start with this particular address, your ending address is going to be 222.511. Okay. Okay. Can this IP address go more than 255? Can it go? Can't. It can't go like that. What is the maximum it can go? 255 only. 255 only. Okay. If you go from 0 to 255, what is the number of addresses you will have? 256 addresses will be there. Okay. 256 addresses will be there. Then you need 512 address. What you have to do? Now what you are going to do? Change this also. Because see, you have some sort of a control of unit this octet number 3 also. Okay. If octet number 3 is 255, can you change anything? Can't. But octet number 3 is 254, which means you can change some sort of value in the third octet also. So after 255 is reached, can you go to 256? No, you have to change the other octet. So if you change the other octet, what is going to be the value? 172.168. After 222, what do you have? 223.0. This also can go from 222.3 to 223.255. Here, how many address you have? Another 256 address. 256 plus 256 address, how much? 512 addresses. Okay. So what is your network address? This. What is your broadcast address of the relevant network? This. Okay. I know some of you all didn't understand. Now listen. 172.168.222.0. Okay, 222.0. Now imagine earlier I took 512 addresses, right? Now you have 1024 address. Now you have 1024 address. If you have 1024 address, tell me from 222.0 to 222.255, how much you can put? 256 address. So if you want to put 1024 addresses like this, how many slots you will need? 4 slots. For 512, 2 slots. 2048 mean 8 slots. Like that you will need. For 1024, you need how many slots? 4 slots. So which mean 222, 223, 224, 225.255 will be the broadcast address. Okay. So again, see here, you start with 172.168.222.0. Okay. You need to go how many addresses? Because you own 512 addresses. The ending address should be matched with 512 addresses. But can you write 511 here? Can't, because the maximum you can go is 255. If you go from 0 to 255, you have 256 address. So in one slot, you can put 256 addresses. If you want more, you have to change the third octet. So third octet will increase by 1. You will receive another 256 address. So first address is this and the last address will be this. Was it clear? Got it? Got it? Okay. I'll give a sample. See, 192.168.0.0. Okay, there are this is the network address. Okay, there are a number of addresses. Number of addresses 1024. 1024. Find me the broadcast address. Find me the broadcast address. Try. Don't look at the board. Try. Right, dance. This is the network address. Find the broadcast. You have 1024 addresses. Okay. Listen, listen. Listen carefully once more. Be silent. Don't talk. So, in the question which they have given, you all can see what is the IP address they have given. What is the IP address they have given? 168.168.222.0/23. Okay, listen carefully. Now, to make you all focus, I need to ask you all the question. Okay. On the other mic. Easy, easy, easy. Don't, easy. On. Okay. Okay, so take the mic to the other side. No, not this side. Come front. Stop there. Give it to that boy. Yes. Give the mic. Okay, so now tell me, what is the what is the CIDR notation here? What is the CIDR notation? Easy question. What is the CIDR notation? CIDR? Then how do you find the number of addresses? How do you find the number of addresses? Formula. Formula. Pass the mic to the other person. Other. How do you find the number of host bits? How do you find the number of host bits? Formula, the main formula. 30? 32 minus 23. Okay, don't be shy. Hurry. Take the mic front. Should I give the girls? No, front. 32 minus 23, what is the answer? 32 minus 23, what is the answer? 9. Wait. Okay, then how do you find the number of address? Number of address. Don't laugh. If you laugh, the mic will come to you. Okay, 2 to the power 9, not 256 minus 9, 2 to the power 9. No, another one. Okay. 2 to the power 9 is equal to how many addresses? 2 to the power 9 is equal to how many address? See, confidently just say the answer. 512 addresses. Okay. Now, the starting address which they have given is 172.168.222.0. Okay, 222.0. Okay. Okay, this zero, what is the maximum value you can take? No, sorry. What is the maximum value you can take the 0 to? 0 to? 255. So how many addresses you will get? How many addresses you will get? 256. If you need 512, like, okay, now enough. Okay, now focus. Anyone who's talking, I'll send the mic. 0.255 Okay, you will get 256 addresses. So if you need 512 addresses, how many slots like this you will be needing? 2 slots. 256 plus 256 is equal to 512. Okay, 512. So can you increase this 255 further? No. So what you have to do, increase the other octet, which means that will become 2223.0. This you can take up to 255. So how many addresses you are having? 256. 256 slot means that means total you have 512 addresses. 512 addresses. So what is the first address? Just say the last two octet, 222.0. What is the last octet? 223.255. That is the network address and the broadcast address of the given network. Was it clear? Tirunada? Understood? Boys, clear? Clear? Okay. Okay. So now, see, listen carefully. So write the answer for the first one. That is going to be 172.168.222.0 to 172.168.223.255. This is the total number of addresses you are having. Okay. Second question. Change the how many subnets can be created, can be made using the above IP address block. Listen. How many subnets can be made using the above IP address block? What is the minimum number of computers you can put inside a subnet? Is it 2, 4, 8, 16? Okay, you can put number of computers inside a subnet as a power of 2. So what is the minimum number of address or computers you can put inside a subnet? What is it? 2. 2. That is 2 is 2 to the power how much? So in 2 to the power 0, 2 to the power 0, 1. Inside one subnet, you can put one computer also. So if you can put one computer inside one subnet, if you have 512 addresses, how many subnets you can create? 512 subnets. So remember, if they ask you a question like that, mark that, okay, equal to the number of addresses. Okay. If they ask you how many subnets can be made using the above given IP address block, make sure, okay, mark it, okay, because that will be asked. Okay. Mark that is equal to number of addresses. Equal to number of addresses. So totally how many addresses you have? To 512 addresses. Okay, 512. Question number 3. State the usable IP address range of the given IP address block. What is the network address? 172.168.222.1. This is the network address. So this is the first usable. What is the last usable? 172.168.223.254. Just add one from here and put, subtract one from here and put, you will get the usable range. What is usable range? Then in between what you have in between network and broadcast is the usable range. Okay. And then you have the subnet table. Listen to this carefully. Okay. Network address, broadcast address, and the subnet mask you have to write. Listen very carefully. So totally, you have how many addresses? 512 addresses. You have 512 addresses. If you want to use the FLSM method, you have to divide this how? Divide this equally. 512, if you have 3 subnets, into how much you will have to divide this? Into 3. Into 4. You have to divide it as a powers of 2 only. You can't divide 3, 5 and all. 512 have to divide it by 4. If you divide 512 by 4, how much you will get? 128. 128. Listen. Now, see the requirement. How many departments we have? 3, which is IT, accounting, and marketing. Okay, in IT department, you have a total of 240 computers plus 2 network printers, and I ask you to add 2 by default for the network and the broadcast. In the accounting department, you have 120 plus 1 plus, you have to add 2. In the marketing, 112 plus 2 plus 2. So here totally how much is needed? 244, here 123, and here 160. You will need this much of IP address. If you use the FLSM method, you totally have 512 addresses, right? You know there are 512 addresses, right? If you want to use FLSM, you have to divide it by how much? 4. Why 4? Because the number of department is 3. You can't divide by 3. You have to divide it by the powers of 2. So 4. If you divide 512 by 4, per department, you will be getting how many addresses? 128. Now we identified the requirement, right? Okay. 128 addresses, is it enough to cover 244? It is not enough. It is not enough. So can you use FLSM here? You can't use FLSM. You can't use FLSM. If you can't use FLSM, you have to go with VLSM. If you want to allocate using VLSM, you have to do. For IT department, okay, totally you need 244 addresses, which means in the powers of 2, if you allocate, how much you have to give? 1, 2, 4, 8, 16, 32, 64, 128, is it enough? No. 256, is it enough? Yes, you have to allocate how many addresses? 256. For accounting department, how much you have to give? 123 mean you can give 128. For the marketing, 128. If you add them totally, how much? Is it enough with the sufficient addresses? Yes. Okay. So now what is the network address? 172.168.222.0. 222.0. For the department IT, how many addresses I'm allocating? 256. I'm allocating 256 addresses. Okay. So if I start from 0, it should end with what? 172.168.222.255. If this ends with 255, this is going to start with 200 256. 223.0. 223.0. You have to increase this by 1. And for the accounting department, you have to allocate 128 addresses, right? Yeah. So if you start from 0, that would end up with 223.127. For the marketing department, it will start with 172.168.223.128. And this will end with 172.168.223.255. See, did I started correctly with the network address? Yes. Did it correctly ended up with the given net broadcast address? Yes. Okay, that is how you do it. And when you ask to find the subnet mask, 255, 255, 255 minus 256 minus 256, 255, 255, 255. The last octet you have to subtract. What is the subnet mask? 256 minus 256, 0. So subnet mask is 0. Here subnet mask is going to be 128 address, right? Both of these are 128. So 255, 255.255, 128. Here also same 255.255.128. That is how you allocate the IP address. Okay, done. Was it clear? Was it clear? Boys, clear? Clear. Okay. If there is any confusion, keep it noted. Others write down the answers. When I come, you can ask the doubts. Online students, why 223? Because you can't increase it after 255. The IT department completely uses 0 to 255. So you can't go for 256 because in IP address, the maximum you can go is 255. So you have to increase the next number, 223. Okay. Sorry. Now the tute is completely done, but again go to page number 5. Okay, so we have missed one. You have still you have one more part to do. What is that? One more part missed in this question. What is it? The network diagram. Okay. How to draw the network diagram? Okay. Listen carefully. Listen carefully. Step by step, I'll explain how to draw a network diagram. Everything which I'm going to mention here should be definitely in your answer sheet. Okay. If not, that would be wrong. Okay. See the rules and everything. Okay. So read the particular description. An IP block 192.147.1.0/24 has been assigned to a network administrator. Okay. The network administrator must assign IP addresses to all nodes in each department. 4 subnets will be set up for this purpose. This network will be connected to a public IP address for internet access of the employees. Each department is located in a different building. See, each department is located in different building. A firewall is installed for the security. Firewall is there, okay, for the security of the network, and 4 switches, necessary network cables, proxy server, DHCP server are provided to the network administrator for this purpose. The accounting information system department is directly connected to the user internet. Okay, with the internet. Okay. So now see here, you have to draw a network diagram. Okay, that's not a question there, but they will ask you to draw. If you want to draw a network diagram, these are the mandatory things. Hari, you should have access to the internet. Okay, the router should be connected to the main department. Also, all the departments should be presented in the relevant diagram. Okay, so now if you want to represent the internet, you can just write like this. That is the internet. Hari. If you want to get connected to an internet, okay, this is a cloud, huh? Not a something. Okay, if you want to connect to the internet, you should have what? You should have what to connect to an internet? Huh? Router. Wi-Fi. What do you need? In a particular department, we call it as in a particular company, we will be calling it as a router. You will need a router to connect to the internet. Okay. So a router is directly connected to the internet. Hari. And this particular router will be directly connected to the switch. Directly connected to the switch. But in order to protect the data which are inflowing and outflowing through the router, we have installed a firewall. What is a firewall? I already explained in the classes. What is a firewall? It is used to filter the data and send in and out the department. Okay. So we are going to use a firewall here. Firewall. Firewall will be connected to the switch. Now, directly, this is how. Firewall router order, if it change, that is no problem. Okay. Hurry. Now, through what department all other departments are connected to the internet? You can read the last sentence. The accounting information system department is directly connected to the internet. So, this department is going to be what? Accounting information department. You have to draw it. The dotted lines you will have to draw. Okay. So what is this department? Accounting Information System Department. accounting information system department. Okay. So now see, in the accounting information system department, what are the devices you are having? How many computers, how many network printers you have? 33 computers, sorry, yeah, accounting information system. You have 33 computers and one network printer. Okay, you have to represent them as well. How do you represent the computers? Just draw a computer like this. Okay, make sure write it as first computer. Okay, and also put another computer and write it as, what is the last computer? 33, 33rd computer. Like this you have to write. Okay, and what else? What are the other department? What are the other things you have? Network printer. You have a network printer. Okay, I'll mark it here. You have a network printer. Network printer, you can just write it as network printer. Okay, that is how you draw the network diagram of the accounting department. Okay, now after that accounting department, we have other three departments. What are them? What are the other three departments you are having? Marketing, sales, and production. You have to connect them to where? Connect them to the accounting department. Why? The main department is connected to the internet. Other department should be connected to the main department. Okay, most of the time it is ICT department or IT department. Sometimes it is information system department like accounting information system. Okay, so you have another two more departments, sorry, three more departments. You have to show them also. One is other one, marketing. Do you have marketing? Yes, marketing department. You have to write the name like this. Marketing department. Draw the switch of marketing department. How many computers you have in the marketing department? How much? 37. So mark first computer and then the 37th computer. 37th computer. How many network printers you have? One. So write that network printer. Network printer. Okay. And what are the other departments? Sales. You have sales. Okay. Sales department will have a switch. Market sales. How many computers you are having? 32. Okay. So mark first computer. Mark first computer and the 32nd computer. 32nd computer. How many printers you have? Two network printers. So you can mark it network printer, network printer. Okay, you can mark them. Hurry. What else you have? Do you have any other thing? No. And then you have the production department. You can draw it. It's too big. Okay. Mark production department here. Production department. And then you have a switch in there. How many computers you have in the production department? 40. 40. So first computer, and then you have the 40th computer. 40th computer. What else? How many network printers? One network printer. Okay, one network printer. Now, all these three departments, when you are drawing in the book, like draw it, align it properly and draw. I am very weak in drawing. So marketing department, production department, and the sales department should be connected to the where? Should be connected to the accounting department. Okay, so you should take a cable from here, connect it, align it and draw, don't go like this. Okay, and connect it here and connect it here. Okay, and also they have mentioned some servers. What are those servers? Proxy server and the server. Proxy server and the DHCP server. Okay, so when you are drawing the proxy server and the DHCP server, you have to draw it in the server, sorry, in the department where it is directly connected to the internet. Which department is connected to the internet? Accounting information system. So proxy and DHCP should be in this particular department. DHCP and the proxy should be there. Okay, and firewall is installed. They have mentioned the firewall is installed. You don't know whether that firewall is a hardware or a software. If the firewall is a hardware, there is no problem. You could keep it like this. But if they haven't mentioned specifically that firewall is a software or a hardware in their particular company, if firewall is a software, in case the firewall is a software, you will be allocating the firewall through what? Through the proxy server, because proxy server acts as a firewall. Okay, so you should put a dotted line connection between the firewall and the proxy server as well. Okay, Hari. And then what you have to do, you have to mark these cables. Okay, you have to mark these cables. In between these, you will be using the twisted pair cables. Okay, you will be using the twisted pair cables. Mark in one department, that is enough. And the main cable, you will be using coaxial, or you can use the fiber optics. You can use the fiber optics. Mark one of them. Twisted pair inside the department and the coaxial cable or the fiber optic exterior to the department. Now is this network diagram complete? Have I mentioned everything which is required? Yes or no? You all don't know. Okay, one more thing is missing. What is that? IP address ranges. Okay, for the each department, you filled and wrote the IP addresses in the table, right? Subnet table, you wrote it, right? That IP address, you have to write it here. Okay, so what was the IP address range for the accounting department? What was the IP address? 192.147.1.0 to 63. 192.147.1, right? 1.0 to 63. Like that, you have to write the range. Okay. No, no. Total range. You have to put the total range. Okay. And then marketing department IP address range 192.147.1.64 to 127. And then you had the production department, and then you had the sales department 192.147.1.128 to 191, right? 191. And at last you had the production department where the IP address range is 192.147.1.192 to 255. Those also you have to put. That's it. If you draw all this is the complete network diagram. Okay, you have to put the cables properly, mark the ranges, put the number of computers, okay, put the cables and name the cables as well, and also the IP address ranges also you have to put. Okay, done. Draw it properly. Yes, you have to connect to the main department. Range එක ලියන්න නැතුව available addresses ගන්න ඉස්සරහට දානවාද? එහෙමයි. ඒ department එකට අදාළ range එක දාලා තිබ්බනම් තමයි ලේසි. ඒතර ඉස්සරහට computers add කරනවා නම් ඔයාට අර network diagram එකකින් බලා ගන්න පුළුවන් තව computers තියෙනවද කියලා. මේ තව allocate space. මොකද්ද? ඔව්. ඒ department එකේ network address එක broadcast address එක අදාළ වෙනවනේ එතනට. Yeah. network and broadcast තමයි දාන්න ඕනේ. ඒක network diagram වල. usable දාන්න ඕනේ. හරි? firewall එක මෙහෙමයි. අර hardware එකක් විදිහට install කරලා නැත්නම් software එකක් විදිහට විතරයි නම් තියෙන්නේ. එතකොට proxy එකකින් නෙවෙයි firewall එක activate කරගන්න ඕනේ. ඒක නිසා පොඩි connection එකක් එතන පෙන්නනවා. එතකොට දාන්න ඕනේ. දාන්න ඕනේ. but most of the time එයාලා silent එක. connect කරන්න.
Ahora vamos a ver, en el salón de
Okay, done drawing? Done? Okay. Shh, 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 shh. Sorry. Shh, shh. Listen. Okay, so with that, the IP addressing and the subnetting part is done. Okay, so we have learned all the methods of related to finding subnet mask, number of addresses, all those things, even with the class B, which means the second octet, third octet changes as well. Okay, so I will be sending a worksheet into the group. Okay, an IP address and subnetting worksheet into the group. In that, there will be uh, 30, no, 25 or something MCQ questions, and you will have 4 essay part questions. Okay, so when you are coming for the next class, Try that, finish it off and come. I'll send it now itself. Shh, 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 shh. 20 MCQ questions and there are 4 struck me essay part questions. I'll discuss them in the upcoming classes as well. Okay, so shh, shh, shh. Yeah, so classes will be continued after this usually, and revision classes will be started next month. Okay, November. Your time, Kiribati timing is fixed Thursday, and Colombo one mostly it would be Sundays morning. Okay, I'll adjust the time and inform you all. Okay, it will be starting from next month, second week. Okay, Hari. So then, bye. Thank you. Have a great day. Not day is finished. Yeah. Thank you.